Once again, good day. I'm Darwin Lazaro, and I welcome you to Advanced System Design and Implementation under Dr. Marcelo B. Abante. For today's topic about design pattern and basic UML as a design notion. Let's start. Let's begin with what is design pattern. A design pattern are well-proved solution for solving the specific problem or task. It is general repeatable solution to the commonly occurring problem in software design. It is a description or template for how to solve problem. So, what are the advantages? Well-proved and testified solution. Solutions are reusable. Language independent. Disadvantages. Design patterns don't guarantee an absolute solution to a problem. Which means, solution doon pa rin siya sa programs or how they build it. Types of design patterns. Under the classification of design patterns, nahati siya sa tatlo: creational, structural, and behavioral. Sa creational, it it concerns with the creation of the objects. Under structural, deal with the composition of classes and objects. And finally, behavioral, deal with the classes and objects, interaction, and contribute their responsibility. Let's enumerate yung mga under ng three categories. Under creational, nandiyan singleton, factory, abstract factory, builder, and prototype. Under structural, adapter, composite, proxy, flyweight, passage, bridge, decorator. And under behavioral, template method, mediator, chain of responsibility, observer, strategy, command, state, visitor, iterator, interpreter, memento. In selecting criteria in, in design pattern, we must find appropriate objects, determining object granularly and specific object interface. Scan intent section. Study how patterns are interrelated. Purpose of patterns, similarities and difference. Examine cause of redesign. What should be the variable in our design? Itong limang to, ito yung dapat na ginagawa natin muna in designing a pattern. Design techniques is composed of two: composition and inheritance, which is the composition is a design of technique in which your class can have an instance of another class as a field of your class. Inheritance is a mechanism under which one object can acquire the properties and behavior of the parent object by extending a class. So, sa susunod na slides, i-discuss natin mas deeper tong dalawang to. Let's discuss about this table regarding inheritance and composition. So, inheritance is a relation. Yan, nakikita natin. So, wherein inheritance, class A is a class B. Parang ganun eh, derived class. Then, dito naman, and building is a base class and derived class is the house, which is makikita nyo dito is a. Then composition is has a relationship. Ito. House has a bathroom, has a kitchen, has a bedroom. Yan. Yan yung composition niya. Well, in inheritance, a class can extend only one interface. Therefore, you can reuse your code only in one class only. Okay. Dito naman sa composition, we can reuse code in multiple class. So, magagamit natin siya, si composition sa lahat. Kumbaga, more in public yan, naka-public. Inheritance provide its features at compile time, while composition is easily achieved at runtime. We can't reuse code from the final class, wherein sa composition, it allows code reuse even from final classes. Okay. So it exposes both public and protected method of the parent class. So sa composition naman, it doesn't expose. They interact using public interface. Ito. That's the difference. After introducing the design patterns, let's go to UML, the Unified Modeling Language, or the UML. Unified Modeling Language is a standard general purpose modeling language in the field of object-oriented software engineering. UML includes a set of graphic notation techniques to create visual models of object-oriented software system. UML techniques from data modeling, business modeling, object modeling, and components modeling, and can be used throughout the software development lifecycle and across different implementation technologies. So makikita natin dito, uh, halos gamit na gamit when it comes sa pagdi-design or sa software engineering. Even in sa pagdi-design ng blueprint, yan, ginagamit din yan eh. Well, makikita natin very useful ang unified modeling language. Kumbaga, makikita na pwede nating sabihin na before we design or forward engineering and reverse engineering. Forward engineering by means of a draft or a diagram, and reverse engineering by means of uh, it's like of taking a picture and then of a system, then malalaman mo kung paano siya ginawa. Yan. That's the main objective. In modeling, there is a difference between UML model and the set of diagrams of a system. A diagram is a partial graphic representation of a system model. The model also contains document that derives the model elements and diagrams, wherein a model is an abstraction that contains all the elements needed to describe the intention of the thing being modeled. These can include all aspects concerning the business, system, relationship, and more, while the diagram is specific view into what are you trying to understand on or in a specific context. The design model builds on the analysis model by describing in greater details the structure of the system and how the system will be implemented. In the design model, packages contain the design element of the system, such as design classes, interface, and design subsystem that evolved from the analysis classes. System modeling is the process of developing abstract model of a system, which is model representing a different view or perspective of that system. It is about representing a system using some kind of graphical notation, which is now almost always based on notation in the Unified Modeling Language or the UML. Below are the sample pictures. Let's discuss about it. The spiral model spiral. So makikita natin dito kung paano yung model spiral. So dito sa requirement analysis or gathering data, yung design itself can be your model, then down to implementation, papunta sa testing. And then evolution is once na meron tayong for production kung may babaguhin, so required analysis again, design or mag-instruct or gagawa ka ng sa UML mo down to implementation, the proper coding, then testing, and so on. Hanggang sa, kumbaga, when you manage to program a application, may mga versioning kayo dyan eh. Yan yung model spiral. Then the other side is the sample of yung paano gumagana si Lazada. Where makikita nyo si customer, si Lazada seller, and logistic provider. So from the picture, start from the customer. So titingin tayo sa gadgets or devices na mag-order tayo. Siyempre, nandiyan yung login nyo, password, protected dyan. Then, once na nakakuha tayo, yung gusto natin, siyempre, i-add to cart natin yan eh. Once na add to cart, ipaprocess na yan. Once na na-process yan, pupunta yan mismo si seller, nakatingin yan mismo dito kay Lazada. So, once na nakita niya, okay na to, may bayad na or on cash, yung cash on delivery or bayad na by credit card or Lazada wallet, i-start niya na yung i-pack. Then, papadala niya si application nung mismong ito, for packing na to or i-status ko nasa na. Once na dumating na yan hanggang sa makarating kay logistic provider, then si logistic provider mag-update yan sa Lazada, then na nakikita ni customer. Then once na nag-update yan, so hanggang sa for delivery na. So awaiting si customer, then si logistic provider diretso na dito kay customer. So that's how the process yung model system yung paggawa ng UML. Dito pa lang sa isang feature na lang na to, naintindihan na natin kung paano gumagana yung business ni Lazada. Why UML for modeling? So, enumerate natin yan. So, use graphical notation for communicate more clearly than natural languages. Encode. Help acquire an overall view of a system. UML is not dependent on any one language or technology. UML moves us from fragmentation to standardization. So from the kaninang previous na features ng UML design ni Lazada, so doon pa lang makikita natin how yung isang system or isang business paano gumagana, yung better understanding. Kaya makikita natin dito, ito yung reason why bakit ba kailangan si UML for modeling. 7 primary goals in the design of UML. First, provide users a ready-to-use impressive visual modeling language so they can develop and exchange meaningful models. Second, provide extensively and specialization mechanism to extend the core concept. Third, be independent of particular program language and development process. Fourth, provide a formal basis for understanding the modeling language. Fifth, encourage the growth of the object-oriented tool market. Six, support higher level development concept. Seven, integrate best practice and methodologies. Okay, let's proceed with the diagrams. Diagram is divided into two sections, structure diagram and behavior diagram. Under structure diagram, class diagram, component diagram, object diagram, profile diagram, composite structure diagram, deployment diagram, and package diagram. And under behavior diagram or activity diagram, use case diagram, state machine diagram, and below the behavior diagram, under interaction diagram, na sequence diagram, communication diagram, interaction overview diagram, and timing diagram. So, i-discuss natin to isa-isa sa mga susunod na slides. So, start tayo sa structure diagram. These diagrams emphasize the things that must be present in the system being modeled. Since they represent the structure, they are used extensively in documenting the software architecture of software system. So let's begin with the class diagram. It describes the structure of the system by showing the system classes, their attributes, and the relationship among the classes. So sa drawing or sa UML na nakikita natin, it's composed of classes. Yan, customer, order, payment, check, cash, credit, yan. Inside it is the mga attributes. And then, makikita natin na may interrelation siya between each class. Iyan ang first na class diagram natin. Component diagram. It describes how a software system is split up into components and show the dependencies among these components. So, sa drawing natin or sa image natin, nasa loob siya ng isang box na order entry tapos represented by component order, component product component, customer component, then papunta sa account. Composite structure diagram. It describes the internal structure of a class and the collaboration that this structure makes possible. So, sa drawing kita natin is similar into yung kanina no, na may class, variable, pero may collaboration. Yan, nakikita natin sa loob. Ito. Yan. Yan ang composite structure diagram. The fourth is the deployment diagram. It describes the hardware used in the system implementations and the execution environments and artifacts deployed on the hardware. Parang sinabi nating imo-model natin dito or yung UML nung bawat hardware, bawat server, kung ano yung composition niya na DB or may apps pa dun, then down to real estate. Ito yung parang mismong dinrawing mo yung per server kung anong meron siya. And next is the object diagram. Shows a complete or partial view of the structure of an example modeled system at a specific time. So, may instance name, yung object, kumbaga, parang it's subdivided and separated with yung parang instance name and class Yan yun. Package diagram. Describe how a system is split up into logical groupings by showing the dependencies among these groupings. So makikita natin dito sa sample, sa example, which is yung packages and dependencies, which is by group yan Then para siyang ang individual niya parang folder no. That's the package diagram. And the last dito sa structure diagram is the profile diagram. Operates at the meta model level to show stereotypes as classes with the symbol stereotype and the profile as package with the profile stereotype. The extension relation indicates what's meta model element a given stereotype is extending. Sa drawing para siyang naka-class with a profile. And yung makikita nyo, yung mga extension relation, solid line with closed filled arrowhead. Yan yung meron siya. Then now, let's proceed with the behavior diagrams. This diagram emphasizes what must happen in the system being modeled. Since they illustrate the behavior of that system, they are used extensively to describe the functionality of software systems. Ito yung mga behavioral diagrams is yung like sa office ko, mas madali nating gamitin to to better understand yung kung ano ba yung system na yung ginagawa mo or to enumerate yung mga process nila from start to end. Yan yung mga basically na behavioral diagrams. Then itong activity diagram, yung first niya, describe the business and operational step-by-step workflow of components in a system. An activity diagram shows the overall flow of control. So makikita natin dito sa sample image natin from start customer ATM machine to bank. Kumaga, ito yung process niya from start to end. So ano yung from the start or the customer? Ano yung magla-login yan or insert card down to ATM na yan Or pagdating dito, magko-communicate sa bank, then ano ipaprocess ni ATM hanggang sa take card, take money from the slot. I-simplify natin into sa office natin. Ano ba yung ginagawa ng customer? Pagpasok nun, isang column yan And then preceded by ano yung next step. Then may mga logical presentation din yan ng mga process niya before going to the third step. And so on hanggang sa final. That's the activity diagram. State machine diagram describes the states and state transition of the system. The third is the use case diagram. Describe the functionality provided by a system in terms of actors, their goals represented as use case, and any dependencies among those use cases. Dito pag gumawa tayo ng use case diagram, mag-stand tayo dyan ng kung ano yung mga actors or mga recipient ng action or doer ng action. From the drawing, the actor patient associated to make appointment. Yan. Kumbaga, yung drawing na patient is association niya is making appointment. Yung use case niya. The actor parang halos i-describe na ng use case. Yan. Patient, cancel appointment, make appointment, scheduler. Then, upon from patient, request medication to doctor, pay bill to clerk. Kumbaga, ito rin yung isa sa useful na if tapos na yung program mo, gusto mong i-introduce yung isang system or application system sa isang division or user, once na naggawa ka ng use case diagram, mas madali mo masasabi kung ano yung ikaw, ito lang gagawin mo, then proceeded siya, ito lang gagawin niya, yung mga ganong scenery. So, susundan natin ng interaction diagrams. These diagrams are a subset of behavior diagrams, emphasizing the flow of control and data among the things in the system being modeled. First niyan, yung communication diagram shows the interaction between objects or parts in terms of sequence messages. They represent a combination of information taken from class, sequence, and use case diagram describing both the static structure and dynamic behavior of a system. So makikita natin dito sa pictures from insert tag down to data manager, order details field, and order and statement, and so on. So this is the example of the communication diagram. The second interaction diagram is the interaction overview diagram. It provides an overview in which the nodes represent communication diagram. There are activity diagrams in which every node, instead of being an activity, is a rectangular frame containing an interaction diagram. Yung makikita naman natin sa example kung ano yung ibig nating sabihin. Third is the sequence diagram. Shows how objects communicate with each other in terms of a sequence of messages. Also indicates the lifespan of object relative to those messages. So, as dito sa example, makikita natin yan kung paano sila nagsasalin-salin. It communicate with each other. Yan. The last type of interaction diagram is the timing diagram, which a specific type of interaction diagram were focused on the timing constraint. So, more in timing to eh. Timing diagrams model sequence of events and their effects on state and property values. Time flows along horizontal axis from left to right. They can be used to show method of execution profiling or concurrency scenario. So, ito yung makikita natin, nagpo-focus lang talaga to sa time constraint. from left to right yung graph niya pagka may visual ka tayo ng graph niya is from left to right talaga. Let's have a brief summary of the UML. UML is very important. It can model any kind of computing system. The system is modeled with a collection of diagrams. Each diagram represents some aspect representing a system. The diagram is there to help you talk about the system with others. UML can help you in forward engineering and reverse engineering. Forward engineering by sketch out, system design, and etc. While reverse engineering generate pictures of existing code to help you understand it. Three modules of UML: sketching, blueprinting, and programming. And the diagram type are structure diagram and behavioral diagram. And I hope you learned some regarding our topic. And thank you for participating and listening. And thank you.